Did you know that your saliva can reveal more about your health than a blood test? Hi everyone, I'm Mohammed Hamama, and welcome to your ASCP preparation camp. Today, we'll explore the fascinating world of proteins beyond blood. From saliva to cerebrospinal fluid, discover how these hidden proteins can provide critical insights into your health and help diagnose conditions like diabetes and neurological disorders. But before we start, don't forget to subscribe to our channel, activate notifications, and like this video. It helps us a lot to reach more medical laboratory scientists. Let's start. A protein world beyond blood, exploring proteins in other body fluids. Blood isn't the only place where proteins play a vital role. Our body fluids, from saliva to cerebrospinal fluid, contain a complex mix of proteins, each with its own function. Analyzing these proteins can be incredibly useful for diagnosing various health conditions. Here's a glimpse into the protein landscape of some key body fluids. Saliva, a treasure trove of information. Saliva boasts a protein composition vastly different from blood plasma. The protein makeup can even vary depending on the location within the mouth where the sample is collected and how it's collected. Beyond the well-known digestive enzyme amylase, hundreds of unique proteins have been identified in saliva using advanced proteomic techniques. Saliva is rich in proteins involved in our body's defense against germs, such as immunoglobulins, antibodies, lysozyme, and lactoferrin. The potential of salivary proteomics. Researchers are actively exploring the potential of analyzing salivary proteins, the salivary proteome, to identify individuals susceptible to dental cavities, gum disease, periodontal disease, and head and neck cancers. Detect conditions like diabetes and cystic fibrosis. Diagnose Sjogren's syndrome, an autoimmune disease, by looking for increased levels of beta-2 microglobulin, beta-2mg, and other inflammatory proteins. Interrogating other body fluids. While the focus here was on saliva, the analysis of proteins in other body fluids like urine, cerebrospinal fluid, CSF, pleural fluid, fluid around the lungs, peritoneal fluid, fluid in the abdomen, and amniotic fluid, fluid surrounding a developing fetus, also hold significant diagnostic value. Unlocking the secrets of body fluids. By delving into the protein profiles of various body fluids, healthcare professionals gain valuable insights into our health and can potentially diagnose and manage a range of conditions more effectively. Demystifying cerebrospinal fluid, CSF. A protein perspective. Cerebrospinal fluid, CSF, plays a vital role in protecting our brain and spinal cord. It's a clear, colorless fluid that surrounds and cushions these vital structures. Understanding the protein composition of CSF is crucial for diagnosing various neurological conditions. Here's a breakdown. Location and production. CSF bathes the brain and spinal cord, constantly circulating and being replaced, turnover, several times a day. The choroid plexus, located within the brain ventricles, is the primary producer of CSF. Protein content. Compared to blood plasma, CSF has a much lower total protein concentration, about 100 times lower. The protein makeup also differs because most large proteins struggle to cross the blood-brain barrier, a protective gateway between blood and brain tissue. Obtaining CSF samples. A lumbar puncture, spinal tap, is the most common method for collecting CSF for testing, usually performed in the lower back. Protein origin in CSF. Over 80% of CSF protein originates from blood plasma through ultrafiltration, selective passage, and pinocytosis, cellular uptake of fluids. The remaining 20% is synthesized within the central nervous system, CNS. Protein distribution in CSF. The protein concentration in CSF gradually increases as it flows from the brain ventricles down to the lower spine, where samples are typically collected. Smaller and medium-sized proteins from plasma, like prealbumin, albumin, and transferrin, are most abundant in CSF. Larger proteins like immunoglobulins, IgG, IgA, IgM, alpha-2 macroglobulin, AMG, fibrinogen, and lipoproteins are rarely found in significant amounts. Normal CSF protein profile. Electrophoresis, a technique for separating proteins, reveals a characteristic pattern in normal CSF. Two notable features are a prealbumin band and two transferrin bands, one at the usual beta-1 position and another at beta-2. The beta-2 transferrin has a slightly different electrical charge due to modifications in its sugar chains. Beta-2 transferrin and CSF leaks. Both beta-2 transferrin and another protein called prostaglandin D synthase can be used to identify leaks of CSF from the nose, CSF rhinorrhea, or ear, CSF otorrhea. However, this method might not be reliable in patients with specific genetic disorders affecting sugar chain formation. Apolipoprotein E, APO, a CSF resident. APO, a protein involved in fat transport within the brain, is another abundant protein in CSF compared to blood. Blood-brain barrier, a gatekeeper. The blood-brain barrier strictly controls the exchange of substances between blood and brain tissue. This barrier limits the movement of many large molecules, especially proteins. Why analyze CSF protein? Measuring total protein and specific proteins in CSF helps detect increased permeability, leakiness, of the blood-brain barrier. Increased intrathecal synthesis of proteins within the CNS. Release of proteins from damaged brain or spinal cord tissue. Conditions affecting CSF protein levels. Increased protein levels in CSF can be associated with various conditions, including viral meningitis, encephalitis, brain inflammation, increased intracranial pressure, trauma, hemorrhage, bleeding, in the brain, demyelinating diseases and immunoglobulins. In conditions like multiple sclerosis, which affects the nervous system's insulating myelin sheath, increased intrathecal synthesis of immunoglobulins, particularly IgG, is often observed. Measuring protein levels in cerebrospinal fluid, CSF. Accurately measuring the total protein concentration in CSF is crucial for assessing blood-brain barrier function. Here's a closer look at why and how protein levels are measured in CSF. Blood-brain barrier and protein leakage. The blood-brain barrier acts as a selective gateway between blood and brain tissue. Normally, this barrier restricts the passage of large molecules, including most proteins, from blood to CSF. Measuring total protein in CSF helps assess the integrity of this barrier. Increased protein levels in CSF often indicate increased permeability, meaning the barrier is leaky. Challenges of CSF protein measurement. Compared to blood plasma, CSF has a much lower protein concentration, over 100 times lower. Therefore, standard methods used for measuring protein in blood need adjustments for increased sensitivity or require a larger CSF sample volume. Common methods in clinical labs. Several techniques are commonly used in clinical laboratories to determine total protein in CSF. Pyrogallol red, this method utilizes a dye that binds to protein, causing a color change. The intensity of the color change is proportional to the protein concentration. Benzethonium chloride, this method relies on the ability of the chemical benzethonium chloride to interact with proteins, leading to a change in solution properties that can be measured. Reverse biuret, this approach measures the amount of unbound copper remaining after it reacts with proteins to form complexes. A chelating dye then binds to the remaining copper, and the resulting color change is used to indirectly quantify protein. Biuret, this traditional method also employs a colorimetric reaction with proteins to estimate their concentration. Convenience of analyzers. Many clinical chemistry analyzers are programmed to use the same basic method, possibly with slight adjustments, for measuring protein in both CSF and urine. This simplifies the testing process. Normal CSF protein levels. The typical reference range for total protein in CSF is 15 to 45 mg per deciliter. Variations in protein levels. It's important to note that protein levels in CSF can vary depending on age. Newborns, both premature and full-term neonates, can have significantly higher CSF protein concentrations, up to 400 mg per deciliter. Term newborns, protein levels in CSF gradually decrease over the first few weeks of life in term newborns, reaching adult levels around 4 months of age. Elderly adults, healthy elderly adults may also have slightly elevated CSF protein levels compared to younger adults. Blood-brain barrier permeability, a deeper look with the CSF/serum albumin index. The blood-brain barrier, BBB, is a marvel of nature, selectively allowing essential nutrients to pass while safeguarding the brain from harmful substances. Assessing its integrity is crucial in diagnosing various neurological conditions. Here, we delve into a specific measure, the CSF/serum albumin index. Why albumin? Albumin, the most abundant protein in blood, is used because it's relatively small and shouldn't readily cross an intact BBB. By comparing albumin levels in CSF and blood serum, we can indirectly assess BBB permeability. The CSF/serum albumin index. This index is calculated by dividing the CSF albumin concentration, milligrams per deciliter, by the serum albumin concentration, grams per liter. To account for unit differences, the serum albumin value is typically multiplied by 1000, converting grams to milligrams. Interpreting the index. A value less than 9 indicates an intact BBB, meaning minimal albumin leakage from blood to CSF. Values between 9 and 14 suggest slight BBB impairment. A moderate impairment is indicated by values between 14 and 30. Values greater than 30 point toward severe BBB disruption. Advantages of the index. This index helps compensate for variations in serum albumin levels, which can occur due to factors like liver problems or malnutrition. By focusing on the albumin ratio, it provides a more specific measure of BBB function compared to just looking at total CSF protein levels. Don't keep this valuable information to yourself. Share it with friends who might find it interesting and helpful. If you have any questions or comments, drop them below. We love hearing from you and will do our best to answer everyone. And for even more insights, grab our free ASCP short notes linked below. They're perfect for study buddies. Hit that subscribe button so you don't miss our next dive into the fascinating world of science.